Good day, ladies and gentlemen. I welcome you all to Shito's mathematics coaching program. Please at the end of this video, I want every one of you to ensure that you share this video and subscribe. Thanks. So today we are going to look at perfect square quadratic expression. So what do you really understand by perfect square quadratic expression? So perfect square quadratic expression is a situation whereby an algebraic expression or a numeral is expressed as the product of two equal vectors. Like, let's say we have 9. 9 can be expressed as 3. 9 can be expressed as 3 times 3. You can see that 9 is expressed as the product of two equal factors, that is 3. Same thing as what? Same thing as 25 can be 5 times 5. That is 25 is expressed as what? As the product of two equal factors. Now we now say that this 25 is called what is called is a perfect square, and 9 is a perfect square, and we have numbers like that. But today we are not going to talk about perfect square of ordinary number. We are talking about perfect square quadratic expressions. So how do we determine, or how do you confirm that this quadratic equation given to us is what is a perfect square? So now if it is a perfect square, so you are taking another form of solving if you are to look for the factors of the particular expression. So now this perfect square expression is expression is generally stated as x squared plus 2xy plus y squared equals to x plus y squared, and also x squared minus 2xy plus y squared equals to x minus what? Y squared. So we have these two expressions. Look at the left hand side of this first one, that is the first one, and the second one. As you can see, what is the difference between this one and this one? The only difference between this and this one is just this. What is just the sign? This is having addition sign, while this one is having subtraction. Are you getting what I'm saying now? So now if you look at this expression, if you see any kind of quadratic equation in form of this, definitely if you are to factor this, so this is how you are going to do it. This will be the form of what? The form of factors of this left hand side. And at the same time to this one, the only thing you just change is the minus whenever your middle term is what is attached to minus, that is subtraction sign. Are you getting what I'm saying now? So now if you look at this one now, so there are two conditions to know before you can determine or you affirm that this expression is perfect square. So I will list out the two conditions now. So the first conditions, I want you to jot it down because of the time I won't have more that time to be writing on the board, but I want you to take out your notes and jot. So now two conditions that must be owed before you can determine or you said this is what is a perfect square. So now let's look at this one now. So now the first one that must be known, that must be ascertained, is what is the first term and the last terms must be perfect square. That is, must be perfect square. And the second condition is that the middle term must be the product of the square root of the first term and must be the twice of the product. That is 2 times the product of of the square root of this and the square root of the last term. I don't know, maybe I'm getting what I'm saying. So let me repeat it. The first condition is that the first term must be a perfect square. The last term must also be a perfect square. That's the first condition. So the second condition is that the middle term must be equal to the twice of the product of the square root of the first term and the last term. Are you getting what I'm saying now? So now let's practice that. So now let's take this one, or this one, anyone. So if you want to take this one now, you want to know whether it is what? It satisfies this equation, it satisfies this expression. So now, what is the first term? The first term is x squared. Now, if you want to know whether this is a perfect square or not, that means you put all of this under what? Under square root. So this square root is what? Is equal to what? This one results to what? Result to x. This one result to x. And also, the last term, that is y squared, put all of these under square root. So what do we have? We have y. That is, the first term is a perfect square because it gives us an exact number, exact value. And also the last term is also what? Is also a perfect square because it results to what? To exact value. Are you getting what I'm saying? It results to exact value. Understand now? So now, if you now want to know this what it means, the first condition is what? Is ascertained. Now, if you want to look at the second condition, so we look at the second condition, that is the middle term, that is 2xy, must be equal to 2 times the product of the square root of the first term, that is x, multiplied by the product of the what? The product of the square, multiplied by the square root of the what? Of the last term, which is y. So what is the result? 2xy. Can you see what do we have here? We have 2xy, we have 2xy. Definitely the two conditions is what? The two conditions are satisfied there. So definitely we said this expression is a perfect square. So far this expression is a perfect square, automatically how do you factor it? You don't need to go through factorization method or completing the square method or quadratic formula before you can get the factor of this. Are you getting it? So far you've already ascertained that this and this, as in this, you've already confirmed that this expression is what? This expression is perfect square. You don't need to go through all that before you can get the factor of the expression. So very simple. So this is what? This is the general form for you. The only thing you are going to do is just that the square root of the first term plus the square root of the last term, which is y, then you square all. That is it. That is it. Very simple. So now I would like to give you one example. That is, I'd like to give you one example. Let's say we are giving, let's say you are given this to determine, you are given this, that is determine one, to determine whether this is what? Is a perfect square. X squared minus 14x plus 49. If you look at this very well, you see that this is what? This is quadratic equation. Yes, this is quadratic equation. That is the general. If you want to compare this, you can see that the general equation of quadratic here is what? Is ax squared plus bs plus c equals to what? Equals to 0. Yes, equals to 0. Oh, okay, we are talking about the expression, so we don't need to write equal sign, not equation. So this is what we have here. So if now I want to compare this one, you can see that this is quadratic equation. And we have methods of solving quadratic equation. You can use factorization method, you can use completing the square method, you can use quadratic formula. But here, before you can. So now, we are given this to determine if it is perfect square. And you know that to compare this to this is what? This is the general expression form. This is the general expression form of quadratic. So now, what are you going to do? So you're now going to look at the two conditions I told you earlier. The first condition is that you put this in the first term, that is x squared, under what? Under square roots, to know whether it is perfect square. Therefore, you see that this one, that is these two, we cancel this one, so we have x. And also the last term, which is what? 49 under what? Under the square root. Therefore, the square root of this one is same thing as, we can write this as 7 raised to power 2. That is 7 times 2 will give us what? 49. So we have what? We have 7. You can see that the square root of this one is x, that is perfect, that is exact value, and the square root of what? 49 is what? Is 7, which give us what? Which give us exact value also. So now some people might be seeing that how do we have x here? How do we have 7 here? So from the law of indices, if you have the square root of a is same thing as a to power half. That is a to power half, 1/2. And let's say we have square here, as we have here, you can see this power multiplied by another power, which is 2. These 2 we cancel 2, we have a raised to power 1, which is equal to a. That is how we got this to be x, and we got this to be 7. You can see that the first condition is what? Is satisfied. So now we're now going to look at the second what? The second condition, whether the second condition also is satisfied. So the second one, that is, the middle term must be equals to 2 times the square root of the first term is what? Is x. While the square root of the fourth of the last term is what? Is 7. So therefore 2 times 7 we have 14. Times x we have 14x. You can see that we see 14x. The result of this one gives us 14x, which is the same thing we have what? We have here. That happen to be the middle term. So now by doing that, it means the second condition is also what? Is also satisfied now. So how are you going to do? So now if you want to do that now, to factor this one now, you can see so far we have x squared minus 14x plus 49. 49, you can see that we have minus there. Definitely, if you remember, let me quickly write. You have x squared minus 2xy plus y squared equals to x minus y squared. Because of this minus here, I'm getting it. So now, therefore, if you want to compare this to this now, so how are you going to do now? To factor this, you from here, this one satisfied, this one satisfied. It means this expression is what? Is a perfect square. So now if you want to factor this one now, this one now be the subtraction, because here we have minus here. Let's say it is plus that we have here, definitely we have plus here. But it's minus, definitely that's why we have minus here. So this one will now be the square root of the first term that we have is x. Are you getting it? Minus the square root of the last term that we got, which is 7. This all squared. Therefore, x squared minus 14x plus 49 is equal to x minus 7 all squared. Can you get that? So this is what? That's the simplicity in that. You can see that you don't need to go to the factorization method before you can get the factor of this. You can see that this results to the what? Results to the product of 2, and this also can be written as x minus 7, x minus 7. That is the product of 2 equal what? Equal factors. That is, this and this will give you what? This. If you now want to know whether you are right or not, make sure, try to multiply this by this again. You see that we have what? We have what we have here. You have this. So which is very simple. So now, let's check another one. That is, let's check another question. Let's check another question. So they said we should determine this, whether it is what? It is s squared. Oh, let me use y instead. So our variable here has turned towards y. Y plus 2y minus 15 equals what? Equals minus 15. No, let me say minus 15. This is an expression here. So now, if you want to look at this one now, you want to do this one now. So you want to confirm, or you want to determine whether this expression is what? Is perfect square. Well, therefore, the two conditions as we did in the first expression. So the first and the second condition for an expression being a perfect square, we need to what? We need to check whether they are satisfied. Now, let's check. The first one is the first term of this expression. If you put it under square root, must give us what? Must give us an exact value, which is y. Good. But look at the last term. The last term is what? Is 15. The last term is 15. So, or let's say minus 15. So, square root of minus 15 will give us 15 what? 15i. Which has led us to what? Which has led us to complex plane, complex value.
and it has to be real. I don't know. It has what? It has to be real. Therefore, this, that is, the first condition is not satisfied. So, since the first condition is not satisfied, we don't need to disturb ourselves. Don't go to the second condition to confirm, because this second one is what? Is depend on the what? On the first condition. So, without getting the first condition, there's no how you can get the second condition. So now from here, you now conclude that this expression is not a perfect square. So you can now say, okay, now I want to use another form of solving. Maybe you use factorization method to solve, or you use completed square methods to get the factor, or you use quadratic formula to get the factor. So this is where we are going to stop today. As I said earlier at the beginning of this video, I want you to ensure that you share this video and subscribe to this YouTube channel. So I remain myself, Shitu. Thank you for today.